Hello, this is Shivam from 44252S, and this is our robot explanation video. And so starting off, there are a couple of things to note. First off, let's go ahead and go with Drivetrain. It's a classic 450 RPM. We have a 2-inch Odom wheel here. That's actually pretty cool. We kind of have it on a bearing. After states, it got bent pretty bad, and so we actually keep on having to push it back right before a match. And there's also this little standoff here that was loosely put in. This is so that whenever driving backwards, there are no chances of blocks accidentally going in. Then we have another thing that's pretty cool. We have a 4-wheel drivetrain. And so back in, I think it was the spin-up season, we can see right here, that's goofy. But back in the spin-up season, there was this one team that did a 8-wheel drivetrain, and the reason they did that was because their bot had a whole lot of weight to it. But with pushback, we're focusing on lighter weight bots that score faster, and so we actually switched back to 4-wheel drivetrain just so that we can easily go over the parking barrier with these sleds. So our bot got pretty mangled up from states, and so I'm going to try my best to explain it. And so next thing to know, we have wing. Wing is cool. We have RoboSource, but wing is cool. Yeah. We have it mounted on this one really long vertical C channel that we mounted everything else on. And yeah, wing is cool. Use wing. It's really good. I think it's meta or something. Then we have hood. Our hood is a bit awkward because it doesn't actually have polycarbonate. And so what can happen is that whenever teams are descoring, it will just push it over. So we actually made it so that the angle we use, first off, whenever we ram into a goal, these rubber bands would actually push the blocks outwards. Second off, we made it so that these spacers right here would stop any blocks from being forced back into the bot. And then you can see here, we actually have 2 stages. And so we have our flap stage right here, and then we have our hood stage, our second stage. So going into intake a bit, it's standard intake. We tuned it in order for it to barely move whenever we're sloping, kind of like 1010G. It's running at 1200 RPM, and we also used a bit of tension on both sides in order to make sure that it doesn't accidentally go up. And we also made it so that there's this tiny gap between the wheels, and so it just barely goes between these two. And so if we go at an angle like this, it'll just barely hit both of these little grooves on the block. Or if we go at an awkward angle like this, it'll actually compress the block, push it to the ground, and we'll funnel it from there. And so we actually use a lot of asymmetric intaking in this robot. And so I can show you real quick. We have our funnels working here. And we actually have just a flat piece of polycarb, just like this. It got pretty mangled at states. I know right here, this is a bit wobbly, but this can compress outwards and inwards, and ultimately it helps with just favoring towards the, from my angle, the left side. And then we have this other polycarbonate. This one is a lot tougher, but can bend back a bit. And so we actually ended up using 2 standoffs right here in order to make it have that slope. Then we also have these flex wheels right here. These are 60p flex wheels. And actually, no, this is a 60p flex wheel, and this is a 30p flex wheel. And the reason we did that was just so that it could actually have asymmetric intaking, because it would compress over here, but it wouldn't compress when it came to the left side. And so whenever it would funnel, it would force one side up while compressing another side so that one side would go up and then score. Then another thing to note is that we actually use pillow bearings to raise this slightly. We actually found in tuning that it lowered friction, so that was pretty nice. Then we have our scraper. I'm going to go into some juicy details later, but scraper is pretty standard. It basically is triangle braced. It bended a lot during states, and so I would not recommend copying this scraper, but we just have it mounted over here, and then we have our what's it called, new gen pneumatic over here. And then it's just a simple standoff. We use a lot of Loctite screws to just stop anything from getting loose. And then we actually have something, it's standard, but it's actually pretty old. If you saw from Overclocked Robotics' old explanation video on the Fun Robotics channel, we actually just have a, high strength axle that just free spins. And so it free spins the whole thing to move this back. And we actually found it was really good for skills, and it was really good for tuning because we had this automatic stopper on both sides just automatically set in. Then we have funnels. These are just standard. Whenever you're going into the loader, it just funnels it and then goes into the flex wheels. And we also use 30p flex wheels for everything just so that it flexes in. Me personally, I would recommend increasing the size gap for match loading and or just cutting up the flex wheels a bit in order to just mesh towards the ball. Then another thing to note, we have a really low friction funnel, and that's really good. We use rubber bands in order to like push back and forth, and they actually stayed intact for the entire 4 months we had the spot, and so that was pretty impressive. Then we have our intake stage. Right now, this just spins in reverse and this spins forward. And so this is really low friction, and so it can just conform to the blocks. It's also pretty loose on about all of the sides in order to just like make sure that it'll, just like skip over blocks. And now time to go onto the hood, which is our juicy part of the bot. And so something to note is that it actually got bent really badly at states, and so it doesn't spin nearly as fast as what it used to. But we found that using a traditional C channel put it at an awkward spacing, and so we used a standoff triangle braced, kind of like with the scraper down here. And then we used to have a hood, but it made our bot out of size, and so we just took it off, and we just found it was pretty useless actually compared to wing. And then we have these stoppers right here with this little bearing setup in order to always get it at a certain angle. Then this can actually flip 180 degrees, but we have a tensioner so that it can automatically push back. And so this made maintenance really easy. And then I would like to also talk about our funnels. Our funnels are really good because we have, just this stopper right here, which will go into our middle wheel mechanism. And it also compresses the blocks, and so there's always some push in order to have the blocks pulling out. And so we actually use a lot of lock nuts, and so I'm pretty sure this bot is around 15 to 16 pounds, even though it doesn't look like it, and so it's pretty heavy. And then this is spinning 1600, this is spinning 1200. We end up taking off one of the chain just to reduce some friction. So I'll demonstrate scoring. So yeah, it's pretty fast. And you're also probably wondering about this. This goes into our middle wheel D-score. And so this is torqued down to around 600 RPM. And so what we have right here, we have a piston. Essentially, it lifts up. And then from there, you can see we kind of have a 1010G setup almost. But this was right before 1010G's triple state mech. We had developed this latch system, and so what happens is that instead of redirecting towards the hood, it redirects towards a bottom roller over here. And so it's just flaps and flex wheels. But we also found that it was really, really good. And so whenever we intake like that, we can keep it into this space. And so during solo wind point or some, we can actually just keep a block right there. We also have these little funnels in order to make sure that the blocks always are straight and will always fill up the center goal. And so the main reason we designed this was just for skills, because we need to get 7 blocks into the center goal for skills in order to hit a 100. And so looking at it from a different angle, it's just we mounted a piston back here, and then if we go ahead and intake, it just falls out like so. And so we also have these middle goal aligners and this little extruded one. We extruded this slightly in order to descore middle goal. It was okay at its job at states because it wasn't nearly long enough, but it still worked. And we have the stopper right here just so that whenever we're ramming into the long goal, it doesn't directly hit the axle. That's basically about it. Wing aligner, it's pretty standard issue. We actually got it from another team. They gave it to us so graciously, and we just repurposed it. And it's definitely spray painted. And then something cool about our bot, it only uses 3 solenoids for the entire thing. And so that saves a lot of air. And so we only have to use 1 air tank. And something cool is that with our code, we use a custom VEX V5, an old VEX V5 template. And so we basically use ODOM and this 2-inch Omni wheel ODOM in order to track our movement throughout our autonomous program. We actually found that even with ODOM, whenever we're driving straight, we perfectly will always go like straight through the parking barrier. But also we added a little latch. And so just in case we can't pass through a parking barrier in skills, we add a latch right there in order to have it slightly lifted from the ground. And so only our wheels would be connecting with it. So if we want to drive forward and backwards in driver skills, we could. And that's about it. The last thing I want to talk about is the aligner. We actually went through about 5 aligners through the 4-month period. And so one thing that stayed constant was that we kept these, and we experimented a lot with different types of aligners, including like gears or like lock aligners, and we just found that standard poly works the best. And so every single aligner was basically standard poly. And the downside to that was the block still went underneath it, and that was really good, but it got scraped up a lot at basically every single time we would use it. So did these. These would bend in, and so it wouldn't funnel the best. And so like we would have to replace it very often. But we found these standoffs right here were really, really effective. And so if you're building an aligner, build these standoff or use a high-strength axle for these aligner parts. All right, that's about it. I'll see you guys at Worlds. We're definitely rebuilding from this design. It's 4 months old. It served its purpose, and we'll miss it. But everybody, good luck at Worlds or States if you're still doing that.